Number 3 then, from the 2017 Mathematics or Mechanics paper, 4 marks. Here we go, velocity and acceleration. The velocity is given as a vector here. You have to find the magnitude of the acceleration when t equals pi upon 6 seconds. Of course, acceleration is like the odd one out of the 3 variables of motion because it's the ambiguous one. You've got distance and displacement for the vector. You've got speed and velocity for the vector. You've only got acceleration. You can't distinguish between what it means. Is it the amount or is it the vector? But here it says quite clearly the magnitude of the acceleration. But anyway, it's fairly straightforward what you do. To get the acceleration, you differentiate the velocity. It's the rate of change of velocity with respect to time. And yes, they've written it out this way with the unit base vectors, which is a bit more of a pest because you've got to put all these brackets and i's and j's and k's, if that was relevant. So much simpler when you can just write it like a coordinate, you know, from the context. But it's not too lengthy here, so I won't complain. So, differentiating it, I'll put that down. dv by dt. In fact, just for doing that, knowing to differentiate, you get a mark. Then we differentiate it. Notice, function of a function. Sine will go to cos, but it's 2t, so it'll be 2 times it, so that'll make it a 6 cos 2t, lots of I. I'll just leave that as a plus and just differentiate the term in the brackets no matter what it turns out to be. Cos goes to negative sine, but again it's times 2, so it's negative 2 sine 2t. 3 disappears because it's a constant, so it can't change. Doing that gets a mark. Now you need to evaluate the acceleration when t is pi upon 6 seconds. So what is the acceleration? Sometimes you do this. What is the acceleration at t equals pi upon 6? Well, that will be, let's do the 6. 6 cos, 2 times that is pi upon 3. Negative 2 times sine, same thing, pi upon 3. Now the substitution gets a mark, but I don't know if it means substitute it and then simplify it. It seems to, in the marking scheme, just give it for the substitution, but now we need to evaluate it. Well, you should know that. Cos of pi upon 3, think in terms of degrees if you like, that would be 60 degrees, is a half, so it's 6 times a half, which is 3, so that's 3i. Sine, however, will be the one it's not, so that'll be the root 3 upon 2, but it's double it, so it's root 3, so minus root 3 j. There's the acceleration, or rather there's the acceleration vector. So what's its magnitude? What's the magnitude of the acceleration? That'll just be Pythagoras in them. I suppose you could say, well, that'll just be a on its own as a scalar without the little tilde under it which says it's a vector. But anyway, it's going to be the 3 squared and the negative root 3 squared. Not that the negative makes any difference, we've just been rigorous there, putting that negative in. So that's going to be 9 and 3 is 12. Root 12, tidy it up, that'll be 4 3's 2 root 3, and that'd be meters per second squared for the last mark. You could of course put that to a decimal, which would be 3.4641 and so on, so 3.46 meters per second squared, but that's such a neat result, I think we would leave it like that.